Welcome to the deep dive. Today, we're really getting into the weeds of modern endpoint security.
Yeah, it's a big topic. Endpoint security sounds technical, right? But it's basically the guard protecting your laptop, your phone, all those devices.
Yeah, exactly. And the way we're tackling this is a bit different. We've got insights from a really detailed set of technical exam questions, specifically about something called Harmony Endpoint.
Which is great because it's not just theory. It's how security pros actually think about setting this stuff up and making it work in the real world.
Right. So our mission really is to pull out the key ideas from these practical questions. We want you to understand the layers, how they work, why they're crucial today.
In these source questions, they're apparently pretty tough, like 96 questions, 90 minutes, 70% to pass.
Yeah, available in English and Japanese too, so it gives us a really granular, practical look. Okay, let's dive in.
Let's do it.
So, thinking about protection, most people probably think it starts when they log in, right? But where does it really begin? Like even before your computer screen lights up properly?
That's a great place to start. Because, yeah, protection kicks in much earlier than most people realize. We're talking before the operating system even loads.
Before the OS. How?
Well, through two key things working together: full disk encryption, FDE, and pre-boot authentication, or PBA.
Okay, FDE. That's encrypting the hard drive, right?
Exactly. Think of it like putting the entire hard drive, everything, the OS, your files, all of it, inside a super strong digital vault.
Okay, makes sense. So what's the PBA part?
PBA is the bouncer at the door of that vault. It pops up before the operating system starts and demands authentication, a password, maybe something else. And crucially, you can't get any data, can't even start loading Windows or Mac OS until you pass that PBA check.
Why is that so important, doing it before the OS?
Because it operates at the hardware or firmware level. It's totally separate from the operating system's own login. So imagine someone steals your laptop. They can't just pull out the hard drive and stick it in another machine to read the data. And they can't boot from a USB stick to try and bypass the Windows login either, because the entire disk is scrambled until that PBA step clears. It stops physical attacks cold right at the start.
Got it. So it's like this fundamental lock way down deep, even before the usual security stuff starts. That's actually pretty powerful.
It really is. It changes the game for physical security.
Okay, so the system boots up securely. We're past the PBA. Now, what about files coming in? You know, downloads, email attachments, the Wild West of the internet.
Right, that's where the next layer comes in, especially for dealing with threats that maybe nobody's seen before, those zero-day attacks.
Yeah, the really nasty stuff. How do you fight something you don't even know exists yet?
Well, one really interesting approach highlighted in these materials is something called the threat extraction blade.
Threat extraction.
Right.
Okay, what does it do?
Its main job is to pull out potentially dangerous active content from files. Think macros and Word docs, scripts and PDFs,
Yeah.
maybe embedded objects, things that could actually run code.
So it's like scanning for bad code within the file.
Not quite. It's more radical than that. Instead of just detecting a threat, it assumes the file might be dangerous. So it takes the incoming file, rips out all that active stuff, and then literally rebuilds a clean, safe version of the file from the safe parts, like a flattened PDF or a Word doc without macros.
Whoa, okay, it reconstructs the file.
Yeah. And then it delivers that clean version to you. The idea is to neutralize the threat proactively, even if it's a brand new attack technique that normal antivirus signatures wouldn't recognize yet.
So it's kind of like a file sanitization service happening on the fly.
Exactly. It's designed specifically to cut down the risk from 0 days, where traditional methods might fail because the threat is just too new. It focuses on removing the potential for harm.
But wait, if it's rebuilding files, doesn't that sometimes break things? Like, what if you need that macro for a spreadsheet to work correctly?
That's the trade-off, absolutely. It's a balance. The system targets known types of active content that are common vectors for attack. For most users, getting a clean, safe file instantly is the priority. But, administrators can configure policies. Maybe certain users or file types bypass extraction if the original active content is essential. It's configurable.
Okay, that makes sense. Flexibility is key there. So we've got pre-boot security, we've got this file sanitization. How does an organization manage all this across, say, hundreds or thousands of computers?
Yeah, that's where the management architecture comes in. And a big concept here is the software blades approach.
Blades, like different tools.
Sort of. Think of it like a modular system. Instead of installing one giant security program with everything switched on, administrators can pick and choose which specific security features, which blades get installed and activated on different groups of machines.
Ah, so you tailor the protection.
Exactly. Maybe the finance team needs heavy data protection blades, but the marketing team needs stronger web filtering blades. You install only what's needed. And the benefits are pretty clear. It uses fewer resources on the actual computers, which is always good. Protection is customized, and deploying the software is more efficient because you're not pushing out features nobody needs.
Okay, that sounds smart. Avoids the bloat. How are these policies actually controlled and sent out?
That's done through centralized management. There's an endpoint policy management service. Its main job is just talking to all the endpoint clients out there, pushing out the policies and collecting logs.
And if a company runs this all themselves, on premises.
Right. In that setup, the clients talk directly to what's called the security management server. That server is the single source of truth. It defines the policies, keeps track of everything, ensures everyone's following the rules. It's central command.
Makes sense. Central control is vital. But how do you initially get thousands of machines hooked into this system and assigned the right policies? Doing that manually sounds like a nightmare. Oh, absolutely. They have tools for that too. One main way is using something called the AD scanner. AD being Active Directory, which most organizations use. You set up a rule, basically, that looks at where a computer sits in Active Directory, its distinguished name, or DN, and automatically assigns it to the right security group with the right policies. It makes large-scale deployment much, much easier.
Automating based on existing structure? Clever. Any other deployment tricks?
Yeah, there's also an endpoint security automatic deployment method. The key thing here is it lets admins push out the initial client software to Windows machines remotely without the user having to do anything. No clicking install, no interruptions.
Ah, silent install. IT teams love that.
Exactly. It just speeds up getting protection onto potentially thousands of machines really quickly and smoothly.
Okay, so the admin side seems pretty well thought out with the blades, central server, and these automated deployment tools. It sounds like you can get quite granular.
You really can. It moves beyond just deploying a single package to actually designing security postures for different roles and risks within the organization.
Right. Now, let's shift focus back to the individual device. Say, my laptop, it's got the client installed. How does it first connect and sort of prove who it is to the management server?
Good question. That initial handshake is critical for trust. When a client connects for the first time to get its policy, it has to go through a user registration and key acquisition process.
So it's not just connecting, it's registering.
Yes. It's establishing a secure, authenticated channel. It gets cryptographic keys, proves its identity. This prevents some random, unauthorized device from just connecting and pretending to be a legitimate company machine to steal policies or cause trouble. Trust is established right at the start.
Okay, trust established, keys exchanged. Now, what happens when I take my laptop home or, I'm working from a coffee shop with doggy Wi-Fi and I can't reach that central management server? Does the security just switch off?
No, definitely not. That would be a huge gap. This is where local policy caching comes in.
Caching, like it saves a copy.
Precisely. The Harmony Endpoint agent running on your laptop keeps a local copy of the last known policy it received from the server. So if you disconnect, you close the lid, you go offline. Whatever the agent just keeps enforcing that last policy it downloaded. Firewall rules, threat prevention settings, access controls, they all keep working based on that cached version.
Ah, so it ensures the protection is continuous, even offline.
Exactly. It's crucial for protecting you when you're disconnected. The security stays active until you reconnect to the network, sync up, and grab any potential policy updates. It provides that always-on protection.
That makes sense. But what if someone's offline for ages, like weeks? Doesn't that cache policy get really out of date? Could that become a risk?
That's a really important operational point. Yes, an old policy isn't ideal forever. The cached policy provides continuity, but it's not meant to be permanent. Systems usually have mechanisms for this. Policies might have built-in timers or rules that say, if this device hasn't checked in for X days, start restricting network access or prompt the user strongly to reconnect. It manages that risk window by encouraging the device to get back online and update.
Okay, good. So there are safeguards against devices going stale indefinitely.
Right. It's about balancing continuous protection with the need for up-to-date policies and threat intelligence.
So here's a final thought for you, our listener, to chew on. We've learned that protection can start literally before your operating system even boots up. How might that idea securing things at the absolute earliest point change how you think about security in other areas of your digital life? Not just your laptop, but maybe apps, online accounts, even connecting to Wi-Fi. Something to ponder.
Good question. Where does security really begin?
Until our next deep dive, thanks for joining us.